Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 5 video on the chapter of time and work where I will solve the remaining problems of exercise 13A on the chapter of time and work from the textbook of author RS Aggarwal. In a previous video, I solved the first I solved the earlier problems from exercise 13A, that is some selected problems from question number 1 to 13, which were based on two general rules of time and work. So these questions, question number 14 to question number 19, is based on the functionality of pipes and cistern. And also I will I have prepared the assignment number 2. The problems of assignment number 2 will be based on pipes and cistern. The PDF link of the PDF of the assignment number 2 will be given in the description below. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you have if you are new to my channel or not yet subscribed, and if you are watching my videos for the first time and my videos are beneficial to you, then I strongly suggest that you support me, and also do not subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I hope you have watched the previous 4 videos on this chapter time and work. If not, then please do watch them so that you maintain the continuity of your study on the chapter of time and work. So let's get started in solving the problems 14 to 19 of exercise 13A on the chapter of time and work. Okay, so I have written down all the problems in the canvas, question number 14 to 19. These problems are from exercise 13A. All these problems are based on the concepts of pipes and cistern. Now, as I always say, when you are solving some problems from any chapter, or even if you are solving, if you are giving a mock test or any exam that contains problems from several chapters, always after solving the problems, always recall or revise the concepts and formulas that was used in solving the problems, so that this will provide a good revision of the concepts of the previous chapters. Regular revision of chapters of any subject is is very important. You must always do this, because if you do this, things will stay in your mind for a longer period of time. Okay, so now let's start solving the problems. Problem number 14 says pipes A and B can fill an empty tank in 10 hours and 15 hours respectively. If both are opened together in the empty tank, how much time will they take to fill it completely? So this is a very standard and straightforward question. So we know that in 10 hours, when a pipe A alone can fill an empty tank in pipe A can alone fill an empty tank in 10 hours, and pipe B alone can fill an empty tank in 15 hours. So we know that the work done. So this is the standard way of solving the problems. So eventually the question is how much time will they take to fill it completely. So both the taps are open, so they are working together. So we have to first find in 1 hour how much work is done by both A and B. If definitely the work done will be positive. Now work done means the part of the tank that is being filled, because the work done will be positive. And if the work done is negative, it means that what part of the tank is being emptied. Okay, so work done by A in 1 hour. Now work done by A in 1 hour also means that part of the tank is being filled when pipe A is working alone. So this will be 1 by 10. This is from the first rule. The first rule of first rule, that is the rule of an inlet, that is a tap that fills a tank. Okay. Similarly, we will have work done by B. In this problem, both the pipes A and B are inlets as they fill an empty tank. So, work done by B by pipe B in 1 hour will be equal to 1 by 15. So essentially, it means that 1/10 of the tank is being filled in 1 hour when by pipe A alone, and 1/15 of the tank is being filled by the pipe B alone. Okay. So what is the work done by both A and B? Work done by when A and B are working together or when they are both open, it is written as A plus B. A plus B means that both the pipe A and B are working together. So work done by A plus B in 1 hour will be equal to 1 by 10 will be 1 by 10 plus 1 by 15. This is equal to 3 plus 2 divided by 30. This is equal to 5 by 30, which is equal to 1 by 6. So in 1 hour, both the work done by A plus B is 1 by 6. Now, whenever from the fact that if you know that in the work done in 1 hour is 1 by n, work done by in 1 hour is 1 by n, where n is positive, then we can say that in n hours the whole tank will be filled. Since n is positive, since in this case 1 by 6 is positive, it means that 1/6 part of the tank is being filled in 1 hour when both the pipe A and B are working together. This is alternatively stated as work done by A plus B in 1 hour. So we can say uh, time taken by A plus B to fill the tank is equal to 6 hours. So 6 hours is the answer. Let me, while I am solving the problem, let me also quickly check whether my answers are coming correctly or not. So this is 14 is 6 hours is the correct answer. Okay. Next problem. So while I am solving the problem, you can pause the video and take screenshot of the solution if you think it will help you. Question number 15. Pipe A can fill an empty tank in 5 hours while pipe B can empty the full tank in 6 hours. So pipe A is an inlet and pipe B is an outlet. And pipe A alone can fill an empty tank in 5 hours and pipe B alone can empty a full tank in 6 hours. Okay. So if both are opened at the same time in the empty tank, how much time will they take to fill it up completely? So definitely, if both the pipe are open, pipe B is outlet, pipe B and pipe A is inlet. If both are open, definitely the work done in 1 hour by both of them has to be positive. Only then the tank will be filled up per hour. So let's see. Work done by A in 1 hour is equal to 1 by 5. Similarly, work done by B in 1 hour, be careful that an outlet work done by an outlet pipe is always negative. An outlet pipe means a pipe that empties water from a tank or cistern. So work done by B in 1 hour will be minus 1 by 6. Minus 1 by 6 since it is given that the pipe B can empty the full tank in 6 hours. Okay. So this implies work done by A plus B, that is when both the pipe A and B are working together or both the pipes A and B are open. So work done by A plus B in 1 hour is 1 by 5 minus 1 by 6. This is equal to uh, 1 by 30. Since 1 by 30 is positive, definitely we can say that water, per hour, water is being filled up in the tank. Okay, so now we can say that if we know that in 1 hour work done is 1 by 30, which is positive, we can say that in 30 hours the whole tank will be filled up. So we can say time taken by A plus B to fill the tank. To fill the tank means to fill the tank completely. To fill the tank completely should be 30 hours. Since the work done by A plus B in 1 hour is 1 by 30, we can say, and since 1 by 30 is a positive, we can say that the whole tank will be filled up by A plus B in 30 hours. So 30 hours should be the answer. Question number 15 is 30 hours. Okay. Let's do question number 16. Three taps A, B, and C can fill an overhead tank in 6 hours, 8 hours, and 12 hours respectively. So both all the three tanks A, B, C are inlets. That is, they are filling the tank. Okay. Now, how long would the three taps take to fill the empty tank if all of them are opened together? Okay. So we have to find uh, from the individual work done in 1 hour of all the three taps. We have to find what is the work done in 1 hour when all of them are working together. Okay. So work done by A in 1 hour is equal to 1 by 6. Since it is given in 6 hours, tap A alone can fill can fill the tank. That is, can fill the tank is completely empty. It will completely fill the tank in 6 hours, and so that which means that uh, the work done in 1 hour by the tap will be by tap A will be 1 by 6, and it will be positive because tap A is filling the tank. It is not emptying the tank. It is filling the tank, or all these three taps A, B, C are filling the tank. So they are all inlets. So work done by inlet is always positive. Similarly, work done by B in 1 hour is equal to 1 by 8. Work done by C in 1 hour is equal to 1 by 12. So this implies work done by A plus B plus C, that is when all the taps are open or all the taps are working together. Work done by A plus B plus C in 1 hour will be equal to 1 by 6 plus 1 by 8 plus 1 by 12. This is equal to the LCM will be 24. So 4, 3 plus 2 by 24, and this is equal to 9 by 24, and this is equal to 3 by 8. So work done by A plus B plus C in 1 hour is equal to 3 by 8. This essentially means that 3 by 8th part or fraction of the whole tank will be filled by the taps A, B and C when they are all working together. So now we can say that time taken, now 3 by 8 we can write it as in the form of 1 by n. It will be 1 by 8 by 3. So now we can say time taken by A plus B plus C to completely uh, fill the empty tank will be equal to 8 by 3 hours. Now 8 by 3 hours, you have to convert it as a mixed fraction and then you have to convert it as hours and minutes. So 8 by 3 hours is 2 and 2 by 3 hours, which is equal to 2 hours, and 2 by 3 hours means 2 by 3 multiplied by 60 minutes, which is equal to 2 hours plus, sorry, not plus, but 2 hours 40 minutes. So 2 hours 40 minutes is the answer. That is, in 2 hours and 40 minutes, the tank, an empty tank, will be filled up when all the pipes are open. That is, all the three pipes A, B, and C are open. Let me check the answer. Question number 16 is 2 hours and 40 minutes. Okay, let's do question number 17. A cistern has two inlets A and B, which can fill it in 12 minutes and 15 minutes respectively. So this time the unit of time is minutes. So it is telling that A and B are both inlets, and A alone can fill the cistern, which is a cistern and tank are same. Inlet A can alone can fill the tank or cistern in 12 minutes, and the inlet B alone can fill the tank or cistern in 15 minutes. Now, an outlet C can empty the full cistern in 10 minutes. So C is an outlet which can empty a cistern which is full of water in 10 minutes. If all the three pipes are opened together in the empty tank, how much time will they take to fill the tank completely? So initially the tank is empty. So that means if all the pipes are open, definitely the work done in 1 hour has to be positive. Only then per hour the tank will be filled up by some water. If the work done in 1 hour by these three taps is come out to be negative, then it means that per hour water is being emptied from the tank, which also means the tank will never get filled up. Anyway, so that was some extra information. So we have work done by A in 1 hour. Since A and B are inlets, the work done in 1 hour by these two taps, that is A and B, will be positive. So work done by A in 1 hour is 1 by 12. Similarly, work done by B in 1 hour is 1 by 15, and work done by the tap C is an outlet, so the work done in 1 hour by the tap C will be negative, that is minus 1 by 10. So now we have to see what is the work done by all of them. By work done by A plus B plus C, that is when all the three taps are working together, or it means that when all the three taps are open. Work done by A plus B plus C in 1 hour is equal to 1 by 12 plus 1 by 15 minus 1 by 10. This is equal to, the LCM will be 60. So 5 plus 4 minus 6. This is equal to 9 minus 3 by 60, which is equal to 1 by 20. So you can see that the work done per hour is positive by A plus B plus C, which means that 1 by 20th part of the tank is being filled in 1 hour when all these three taps are working together. So we can say that time taken by A plus B plus C to completely fill the tank is equal to 20 minutes. 20 minutes, since the units of all the time in this problem is given as minutes. So the answer should be 20 minutes. Let me check the answer. Question number 17 is 20 minutes. Okay. Let's do problem number 18. A pipe can fill a cistern in 9 hours. So, so the pipe is an inlet. Due to a leak in its bottom, the cistern fills up in 10 hours. Due to a leak in its bottom, the cistern fills up in 10 hours. Okay, so it is taking more time because there is a leak in the pipe. If so, without so it means that without the leak, if the leak was not there, then the pipe can fill the tank in 9 hours. And since there is a leak, so definitely some water will come out. So that leak will work as an outlet. That leak will work as an outlet. So definitely the pipe will take more time to fill the cistern, and so it is given that with the leak, since there is a leak, it actually takes to fill the tank completely, it actually takes 10 hours due to the leak. But if there was no leak, then it would take 9 hours to completely fill the tank or cistern. Okay, now if the cistern is full, how much time it will take by the leak to empty it? Okay, so we have to consider the leak as an outlet. So basically it is asking what is the time taken by the leak, or you can consider it as an outlet to completely empty a filled tank. Okay, so basically we have to find what is the work done per hour by the leak. Okay. uh, hmm. If the cistern is full, okay. So okay, so basically we can solve this problem in two ways. You can assume that we need to find now the leak. Definitely the leak has some the leak will be doing it will have some work done per hour, and it will be negative. We don't know. Usually we know the work done per hour by a tap from the given fact that how much time it takes to to either fill an empty tank completely or to empty a filled tank. But so we do not know that fact about the leak, but we do know that when the pipe along with the leak fills up the tank in 10 hours. So let me assume that let so let the leak empties a full empties let the leak empties the full tank. Let the leak empties the filled tank, that is completely empties the filled tank in X hours. Okay. Now it is given that the pipe can fill a cistern in 9 hours, that is without the leak. So we can say that work done by, now let's say we let the pipe be, we are abbreviating the pipe as A and let's say the leak as L. So this is the leak, that is L, empties. We are assuming that the leak empties the fill tank in X hours. That is, the tank that is in X hours, a completely filled tank will be emptied by the leak. Now, now we can say what is the work done by the pipe alone. That is the pipe A. So work done by A in 1 hour is equal to 1 by 9. Since it is given that without the leak, the pipe can fill a cistern in 9 hours. So we have the work done by A in 1 hour is 1 by 9. And from the assumption that the leak empties the fill tank in X hours, we can say work done by L, L means the leak, in 1 hour is equal to minus of 1 by X. Minus of 1 by X because the leak is working as an outlet. So the work done by an outlet is always negative. So minus of 1 by X. So this implies work done by A plus L. Now what is A plus L means? A plus L means the pipe along with the leak in the bottom. So work done by A plus L in 1 hour will be equal to 1 by 9 minus 1 by X. Okay. Now work done by A plus L in 1 hour is 1 by 9 minus 1 by X. Okay. Now it is also given that due to a leak in its bottom, the cistern fills up in 10 hours. In 10 hours. Now from this fact, since we know that the work done by the pipe along with the leak in 1 hour is 1 by 9 minus 1 by X, which is equal to, if you simplify, this is X minus 9 divided by 9 by X. Okay. Now, so this implies that now this can be written as 1 by 9x by x by 9. From the fact that work done by A plus L in 1 hour is 1 by 9x by x by 9, we can say that time taken by A plus L to completely fill the empty tank will be equal to 9x by x minus 9. 9x by x minus 9. Since we know that if work done in 1 hour is 1 by n, and assuming that n is positive, then we can say that in n hours the whole tank will be filled up. So we have this. The time taken by the pipe and the leak to completely fill the empty tank is 9x by x by 9, x minus 9, and it is also given that due to a leak in its bottom, the cistern fills up in 10 hours, which means that the pipe along with the leak completely fills the empty tank in 10 hours. So we must have then 9x by x minus 9 should be equal to 10. Should be equal to 10. Now this implies we have to solve it. This is a linear equation in x. So we have 9x using cross multiplication. We have 9x is equal to 10 multiplied by x minus 9. This implies 9x is equal to 10x minus 90, and this implies x is equal to 90. So the assumption, what is x? X was, as per our assumption, we assume that the leak empties the fill tank in x hours. So we can now say that the answer is 90 hours. So this is 90 hours. That is, the leak itself will completely empty a filled tank in 90 hours. So that is what the question is asking. If the cistern is full, how much time it will take by the leak to empty it? So the answer should be 90 hours. Let me check. Question number 18 is 90 hours. Okay. Question number 19. Pipe A can fill a cistern in 6 hours and pipe B can fill it in 10 hours. Both the pipes are opened and after 2 hours pipe A is closed. Okay, how much time will B take to fill the remaining part of the tank? What is given? Pipe A can fill a cistern in 6 hours and pipe B can fill it in 10 hours. So both the pipes A and B are inlets. They are filling the tank. Okay. Now both the pipes are opened and after 2 hours, so for 2 hours both the pipes are working, and after 2 hours pipe A is closed. So definitely some part of the tank would have been filled and some part will be empty. Now it is asking how much time the pipe B will take to fill the remaining part of the tank. So for this we have to first find what is the remaining part of the tank after 2 hours. Okay, so let's solve it step by step. So work done by A in 1 hour is equal to 1 by 6. That is, 1/6 of the tank is filled in 1 hour by the tap A alone. Similarly, work done by B in 1 hour is equal to 1 by 10. So this implies work done by both the taps A and B when they are working together, or when both of them are opened, that is work done by A plus B in 1 hour will be equal to 1 by 6 plus 1 by 10. This is equal to the LCM will be 30. So 5 plus 3 by 30. This is equal to 8 by 30. So this means that 8 by 30th part of the tank is filled in 1 hour when both the taps A and B are open. Okay. Now it is given that both the taps are open for 2 hours. So we need to find work done by A plus B in 2 hours. Using unitary method, this will be equal to 8 by 30 multiplied by 2, which is 8 by 15. Okay. So we see that now what does it mean that work done by A plus B in 2 hours is 8 by 15? It basically means that 8 by 15 part of the tank is filled up in 2 hours. So we can say this implies that part of the we can say that what is the remaining part, remaining in the problem it is asking how much time will we take to fill the remaining part of the tank. The remaining part of the tank means the part of the tank which is still empty. So remaining part of the tank will be, of course, the whole tank is 1 and 8 by 15th part of the tank is already filled up in first 2 hours. So we can say the remaining part of the tank will be 1 minus 8 by 15. This is 7 by 15. So 7 by 15th part of the tank is still empty or remaining after 2 hours. Now we have to find how much time B will take to fill this 17 by 15th part of the tank. So this we know that in 1 hour, now this will be, now I have already discussed the concept that if you know that a pipe, if we know that pipe B, if we know that what is the hours in which pipe B alone fills an empty tank, from that information we can find how much time the pipe B will take to fill a certain part of the tank. So we can say time taken by B to fill 17 by 15th part of the tank will be equal to 17 by 15 multiplied by 10, multiplied by 10. That is, if we are given, so for a pipe, if you know that if a pipe fills an empty tank completely in n hours, and if you are asked that how much time the pipe will take to fill p by qth part of a tank, then the answer will be p by q multiplied by n. So this is if I so this will be 5, 2 and 3. So 14 by 3 hours. Okay. 17 by 7 by 15 multiplied by 10 is 2 and 3. Okay. So this 14 by 3, we have to convert 14 by 3 hours as hours and minutes. 14 by 3, if we convert it as mixed fraction, will be 4 and 2 by 3 hours. Now 2 by 3 hours we know is equal to 40 minutes. So this is equal to 4 hours 40 minutes. So the tab B will take 4 hours and 40 minutes to fill the remaining part of the tank, and the remaining part of the tank was 7 by 15. So let me quickly check the answer. Is question number 19 is 3 hours and 20 minutes. Why it is 3 hours and 20 minutes? The answer is 3 hours and 20 minutes. Okay. Now let me see if I did it correctly or not. So work done by A in 1 hour is 1 by 6, and work done by B in 1 hour is 1 by 10. So work done by A plus B in 1 hour is 1 by 6 plus 1 by 10, which is equal to 5 plus 3, 8 by 30. Okay. So work done by A plus B in 2 hours, since it is given that both the pipes are opened and after 2 hours pipe A is closed. Okay. So for 2 hours the pipe A and B were working together. So work done by A plus B in 2 hours will be 8 by 30 multiplied by 2, which is 8 by 15. 8 by 15. Okay. So the remaining part of the tank should be so work done in 1 hour means whatever the fraction is, that means that if the fraction is positive, it means that that part of the tank is filled up. That is 8 by 15th part of the tank is filled up. So the remaining part of the tank will be 1 minus 8 by 15, which is equal to 7 by 15. Okay. So the 7 by 15, so now we have to find how much time it will take for pipe B to fill 7 by 15th part of the tank. And it should be 7 by 15 multiplied by 10. 5, 3, 5, 2. So 14 by 3. 14 by 3. 14 by 14 by 3. 14 by 7 by 15 multiplied by 10 is 5, 2, 5, 3. 14 by 3. 14 by 3 is 4 and 2 by 3. So it should be 4 hours and 40 minutes. Why the answer is 2 hours, 3 hours and 20 minutes? I have no idea. Let me quickly check if I have written the problem correctly or not. Uh, oh, sorry. Pipe A can fill Cistern is 6 hours and pipe B can fill it 8 hours. Sorry. So this is 8 hours, not 10 hours, but 8 hours. So this is 8 hours. Okay. So this is 8. This is 8. This will be 8. Sorry, I incorrectly copied the answer. So this is 8. Now 1 by 6. 1 by 6 plus 1 by 8 is how much? 4 plus 3 by 24, which is 7 by 24. Work done by 2 hours will be, work done by both the pipes in 2 hours will be 7 by 24 multiplied by 2, which is equal to 7 by 12. So 7 by 12th part 7 by 12th part of the tank is filled up in the first two in 2 hours by both A and B. So remaining part of the tank will be uh, remaining part of the tank will be 1 minus 7 by 12, which is 5 by 12. So now we have to find how much time the pipe B will take to fill 5 by 12 part of the tank, which will be 5 by 12 multiplied by 8 is 5 by 12 multiplied by 8, which is equal to uh, 2. So 10 by 3. 10 by 3. 10 by 3 hours, which is equal to, in the mixed fraction, it will be sorry, 10 by 3 and 1 by 3. So 3 and 1 by 3 hours means 3 hours, and 1 by 3 hours means 20 minutes. So 3 hours 20 minutes. 3 hours and 20 minutes should be the answer. Okay, 3 hours and 20 minutes. Okay, so this was all the remaining problems of exercise 13A, which were based on pipes and cistern. So these are very straightforward problems, and these are not at all hard. But I think solving these problems will give you a good clarity of how the fundamental concepts are being applied to solve the problems on pipes and cistern. The problems that I have given in assignment number 2 will be very conceptual. That if you can solve all the problems of assignment number 2 correctly, that will definitely you can definitely know that your concepts are well tuned up. Your concepts are you have understood the concepts well. Even though I will solve more harder problems in the other playlist, that is Maths 8 Hard. I will start preparing and solving 10 good problems in that playlist on the chapter of time and work very soon. So I hope this video was beneficial. It should give you a good clarity of how to apply the concepts of pipes and cistern to solve this kind of problem. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So the next video I will upload will be on solving the problems of assignment number 2, which I will upload in the next 24 hours. So thanks for watching, and until the next video, take care and bye.